This video is going to be on lesson 1.4 in limits, and I'm going to be doing this lesson in two parts. Remember that one of the main goals in calculus is to be able to find the slope on a curve, any curve at any given point. So if I was given this curve here and I was asked to find the slope of this curve at this point here, I'm going to call that point P. The slope at that point, if I draw a line through it, what I've just drawn is the tangent line going through point P. So I'm just going to call this the tangent line. I need to say what the coordinates of point P are. So the x coordinate would be A, and the y coordinate would be over here, and that would be f of A. So point P is at A, comma, f of A. If I needed to find the slope of this line at that point, I only have 1 point. We know that in order to be able to find the slope of a line, we need 2 points. So what we do is we introduce a second point on the curve, and we're going to call that second point, point Q. So I'll have point Q right here. So it has to be the second point on the curve. If you connect the 2 points on the curve, you've just put in what's called the secant line. And I'll just denote that by L. Okay, we need to know what the coordinates are on the second point, which is going to be Q. So I'm going to say that this is X, and then the Y value over here would be f of X. So now we have our 2 points. With these 2 points, I could calculate the slope of the secant. So the slope of the secant would be at PQ. So the slope of PQ is going to be, the equation for to find the slope is y2 minus y1 over x2 minus x1. The point that we introduced, the q value, that's going to be our x2, y2, and this is going to be x1, y1. So y2 minus y1 would be f of x minus f of a. All over x2 minus x1, which would be x minus a. That's going to give us the slope of PQ. Okay, it's going to give us the slope of the secant line. The goal, though, is to bring point Q closer and closer to point P. So essentially what we're doing is we're going to be bringing this x coordinate closer and closer to the x coordinate on the line of our tangent. So what we are doing is we are bringing Q closer to P, which means we're bringing x closer to a, and this is going to give us the first formula, or formula 1, which is going to be the slope of our tangent is going to be the limit as x approaches a of y2 minus y1 over x2 minus x1, which was right from here. So f of x minus f of a all over x minus a. This is what we're going to call Formula 1, and we're going to do 4 examples applying Formula 1, and then the second part of the video will be, we'll derive Formula 2, and then we will apply Formula 2. So let's look at this first example here, and it says find the slope of the tangent to this curve. So we have a parabola here, and this is the slope, this is point P. Okay, we're going to find the slope at that point on this curve. So what you need to realize is a few things. For this point here, I'm just going to write it off to the side, so 2 comma 6. If this is our point P, that means that this is our A, and this would be f of A. So f of A is going to be equal to 6. How you find f of A is in this function here, if I take out the x and I put in my A value, which is 2, I'm going to take out any x in the equation, and I'm going to put in 2, substitute in 2. So 2 squared plus 2. The f of 2 is equal to 4 plus 2, and f at 2 is 6. So on this point here, the x value, which is a, is 2, and our y value is 6, and that's going to be our f of a. Okay, so let's write the formula. So we're always going to start out with the slope of our tangent is equal to the limit as x approaches a of f of x minus f of a all over x minus a. We know from here what a is. So we're going to say this is equal to the limit as x approaches 2, right? That's our a value. As x approaches 2 of f of x. What was our function? Our function was x squared plus x minus f of a, and f of a was right here, minus 6, all over x minus a, which is x minus 2. I cannot put 2 in here. I'll have an indeterminate value. I'll have 0 over 0. So we're going to need to use algebra so that we will no longer be indeterminate. So this is going to be the limit as x approaches 2. So if you factor the numerator, the two numbers that multiply to negative 6 and sum to 1 would be x plus 3 and x minus 2. All over x minus 2. This will cancel, and we will be left with the limit as x approaches 2 of x plus 3. I'm able to substitute in now, so I don't need to use limit anymore. I could just substitute 2 in for x. So 2 plus 3 is equal to 5. And that is going to be the slope of our tangent line. If they asked then to find the equation of the tangent line going through that point, remember the equation of the tangent line would be y minus y1 is equal to the slope x minus x1. So that would be y minus 6 is equal to the slope, which we just calculated of the tangent is 5, and then x minus 2. And then you would distribute in your 5 here. Y minus 6 is equal to 5x minus 10. And if it doesn't say to solve, to put it in general form, I'm just going to put it into y is equal to mx plus b form. So I'm going to add 6 to both sides. And the equation of the tangent line would be y is equal to 5x minus 4. So that would be the tangent line. Okay, let's look at this example. Find the slope and the equation of the tangent line to that given curve. So there's our curve, and there's the point on our curve. So this, remember, is point P that lies on our curve. This, if that's point P, and we're finding the tangent at that point, this is our A value, and this would be f of A. So f of A is going to be 15. Again, if you were only given the x coordinate, you would take 2 and you would plug it into the function, and that would give you a y coordinate at 15 if you evaluate it. So the slope of the tangent line is equal to the limit as x approaches a of f of x minus f of a all over x minus a. Again, we know what our a values are. Our a values are 2. I know what f of x is. My function is right here. And then I know what f of a is. F of a is 15. So we could then say that is equal to the limit as x approaches 2 of f of x, which was 2x squared plus 4x minus 1 minus f of a. F of a was 15. And that's all going to be over x minus a, which is x minus 2. Let's clean up the numerator. So we would have the limit as x approaches 2 of 2x squared plus 4x minus 16 all over x minus 2. Remember that this is going to be indeterminate if we substitute in at this point our x is equal to 2, so we need to use algebra so that something will cancel. In the numerator, you could factor out a 2. And then from here in the numerator, we could factor by inspection this trinomial. So that's going to be the limit as x approaches 2. The two numbers that multiply to -8 and sum to 2 are going to be 4 and -2. So x plus 4, x minus 2, x minus 2. Here we have our factors that cancel. And now we are left with the limit as x approaches 2 on that curve of 2x plus 4. We are able to substitute in now since I was able to get rid of that denominator and I won't have a 0 on the denominator or in the denominator. So it's going to be 2 plus 4, 2 times 6, and that would give us 12. What we just calculated is the slope of the tangent. The question says, what is the slope of the tangent line and the equation of the tangent line? So we're going to find the equation of the tangent line at that given point on this curve. So if that's the slope and the point on the curve is 2, 15, we could find the equation of the tangent line by using the formula y minus y1 is equal to the slope x minus x1. So let's see what we would get. Y minus 15 is equal to the slope, which is 12, x minus 2. Let's distribute in that 12. Y minus 15 is equal to 12x minus 24. And then add 15 to both sides, and you are going to get the equation of the tangent line to be y is equal to 12x minus 9. So again, that's the equation of the tangent line. That tangent line would go through that point, 2, 15. The tangent line has a slope of 12, which is what we calculated. The tangent line itself would have a y-intercept of -9. Okay, we'll look at 2 more examples and then we'll derive the formula number 2. So it says find the slope of the tangent to f of x at this point. So again, this is our curve. This is the given point on the curve, and we're going to find the slope of the tangent going through that point. So this is going to be my a value, and this is going to be f of a. The slope of the tangent is equal to the limit as x approaches a of f of x minus f of a all over x minus a. Again, we know what a is. We know what f of x is. Our given function is right here. And then we know what f of a is 1/3. So we could say from here, this is equal to the limit as x approaches 5 of f of x. So my given function was 1 over x minus 2 minus f of a, and f of a is 1/3, all over x minus a, which would be x minus 5. Okay, right now we get an indeterminate answer. We'd have 0 over 0. So if you have rationals, remember you're going to be getting common denominators. So let's clean up the numerator by getting common denominators. If I have a 3 over here, I'm going to multiply this by 3. And then if I have an x minus 2 for the left fraction, I'm going to multiply this by x minus 2 and x minus 2. So what I've done now is my denominator is 3x minus 2. So let's clean this up. The limit as x approaches 5 of, so this is going to be 3, and I'm going to distribute in this -1. So that would be minus 1x plus 2 all over 3 x minus 2, and then that is over x minus 5. Now remember, we're going to have two fractions, because this x minus 5, I could put it over 1. So what I'm going to end up doing is, instead of dividing this fraction by this fraction, I'm going to take this fraction and multiply it by the reciprocal of this. So that's where we're going to be going. So let's actually get there. This is equal to the limit as x approaches 5. I'm going to clean up this top fraction. So I would have 3 plus 2 is 5 minus 1x all over 3x minus 2. And instead of dividing it, like I said, by the denominator, I'm going to multiply it by the reciprocal. Okay, so we know that these two are going to cancel, but it's not ready to be canceled yet. I'm actually going to rewrite this as negative 1x plus 5 because I want it to be more, to look like this. So let's write that as negative 1x plus 5. It still can't cancel. So you have to say to yourself, well, how could you get that factor to cancel with this factor? If you factor out a negative 1 from here, you're going to have x minus 5. So what I'm showing, or what I'm trying to say is, from this, if I factor out a negative 1, I will have x minus 5. And then you will have x minus 5 and x minus 5. Those two would cancel. So this would cancel with this. That would leave us with the limit as x approaches 5. My numerator has negative 1, and my denominator would be 3 times x minus 2. I'm now able to substitute in. So negative 1 over 3 times 5 minus 2. That would be equal to negative 1 over 3. Take care of your bracket. 5 minus 2 is 3. And that would be equal to negative 1 over 9. So the slope of my tangent curve is equal to negative 1 over 9. It didn't ask for us to find the equation. It will on the next one, where we're going to have a slope that is a fraction. So we'll do that there. Okay, last one, we're going to be applying Formula 1. So here's an example of, again, it gives us our function. Okay, so on the curve of this function, they want us to find the tangent at this point here, but it does not tell us the y-coordinate on that point. So x is 13. We need to find out what y is. So into the function, if I input 13, it's going to be 2 times 13 minus 1. That would be 26 minus 1. Square root of 25, which is 5. So the point on the curve that we're finding the tangent of is going to be at 13, comma 5. Again, that is your A, and this is your f of A. So the slope of the tangent is equal to the limit as x approaches A of f of x minus f of A all over x minus A. And again, we know what A is. A is 13. We know what my given function is. We're going to be finding the tangent on that curve. And f of A, f of 13, is going to be 5. So the limit as x approaches 13 of f of x, so this is my f of x, minus f of A, which is 5, all over x minus A, x minus 13. Whenever you have a radical, you know that you're going to be rationalizing. And we're going to be rationalizing the numerator. Right now, I cannot enter 13 into the denominator because I'll have 0, and it'll actually be indeterminate. We'll have 0 over 0. So we've got to clean this up algebraically, so something will cancel. Okay, The conjugate of the numerator would be the square root of 2x minus 1 plus 5. And I'm going to multiply numerator and denominator by that conjugate. This is going to be equal to the limit as x approaches 13. Remember, when you're multiplying conjugates, you could take the shortcut. First term times first term would be 2x minus 1. And then last term times last term, negative 5 times 5 would be minus 25. Keep your denominator in factored form because the goal is to cancel. So I don't want to distribute if we're wanting to cancel. Okay, let's rewrite this now. I could simplify the numerator. So the limit as x approaches 13, that would be over, numerator would be 2x minus 26 all over x minus 13. And then this would be the square root of 2x minus 1 plus 5. Hopefully you could see from this numerator, if I factor out a 2, I'm going to be left with x minus 13 if I factor out a 2 from here. So I'm going to erase this, and I'm just going to rewrite that. So factor out a 2, and you'll be left with 2 and x minus 13. Here are the two factors that will cancel. And what I am now left with, which I'm going to write, is going to be the limit as x approaches 13 of 2 over the square root of 2x minus 1 plus 5. I'm ready to substitute in, so I could drop writing limit, and I could just simply substitute in at this point. So 2 over the square root of 2 times 13 minus 1 plus 5. 2 times 13 is 26. 26 minus 1 is 25. Square root of 25 is 5. And that is going to reduce to give us the slope of our tangent at 1 over 5. Okay, it also says to calculate the equation of the tangent. So we're going to do that, and this will be good practice because we have our slope is a fraction. So let's figure what that would be. Y minus y1 is equal to the slope x minus x1. Y minus y1 was 5, right? So remember the given point, the y value is 5. So y minus 5 is equal to 1/5, and then it was x minus 13. From here, I'm going to actually get rid of that denominator of 5. So I'm going to multiply this side by 5, and I'm going to multiply this side by 5. And I would get 5y minus 25 is equal to, this will cancel, and I'm distributing in from here a 1. So I'm going to have x minus 13. What I would do is the majority of the time you're going to be told to put your equation in general form. So I'm going to go into general form. If we needed to go into y is equal to mx plus b, we would just add 25 to both sides and then divide everything by 5. But let's go into general. So into general, we want to bring everything to the side that makes our x positive. So I'm going to bring everything to the right-hand side. What that would give me is x minus 5y, and then negative 13 plus 25 would give me plus 12. And that would be the equation in general form. This is going to be the entire assignment that you're going to be doing on lesson 1.4. And what I would recommend before you do the second formula, I would do some of these questions. So I'll show you what the textbook is going to look like. It's going to give you a question. So question number 1 I assigned, question number 2 I assigned, and it says find the slope of the tangent line to this curve here at this point, right? So here's your A, here's your f of A, and then it says find the slope using Formula 1 and then find it using Formula 2. So I would start this homework by using Formula 1, like go through your Formula 1 since we know how to do a couple questions with Formula 1. And then when we're done, you're going to be going back, you're going to watch the second part, which will be introducing and applying Formula 2. And then you could redo those questions using Formula 2.